In this next bit of information, we're told the uncertainty in t squared for 1 over h equal to 10 is shown on the graph. Well, let's see what they are talking about over here. We've already mentioned the error bars on the graph, and let's just analyze that a little more closely. We read off that value like so. We see this one here is a little bit darker, and it's about 2 below that. So that would make this 2.9. So we would say this value is 2.9. And then looking more closely, we see 1, 2, 3, 4, 5, 6, 7. So 0.05 times 7 gives us 0.35. And so that looks like it's a plus or minus 0.35. Check it going upward as well. We have 1, 2, 3, 4, 5, 6, 7. So we get it confirmed there as well. So we would say that this value is at a 1 over h of 10 is 2.9 plus or minus 0.35. So we now know what they're talking about, and we've done a little work on it. State the value of the uncertainty. Oh, we've already done that. Plus or minus 0.35. And the vertical axis is time squared. So that would have units of seconds squared. The next question, calculate the uncertainty in t squared when t is 0.8 plus or minus 0.1. Well, let's get a sense of what this really means. We have our values of t, and so our mean value, our accepted value is 0.8. It could be as large as 0.9, that would be our upper limit, and it could be as small as 0.7, that's our lower limit. Well, what would then t squared be? That would be 0.81, 0.64, and 0.49. Oh, we can see then that t squared is 0.64. And if t squared is 0.64, what is the plus or minus associated with that? The absolute uncertainty is always the upper limit minus the lower limit over 2. These two divided by 2 should put the mean right in the middle. 0.81 minus 0.49 all over 2. That gives us 0.32 over 2, which is 0.16. And again, that's seconds squared because we're talking about the vertical axis. However, the absolute uncertainty, which may be plus or minus 0.16, all uncertainties can only be expressed to one significant digit. So that means the absolute uncertainty is really then plus or minus 0.2 seconds. And that is our uncertainty in t squared. Use the graph to determine the value of k. We said that the slope is k squared. And if we want k, we need to find the slope. The first thing we want to do is state explicitly that we are aware that the slope is k squared. The slope equals k squared. So k is the square root of the slope. So k is the square root of the slope, which is then the square root of delta y over delta x. Typically in a question like this, we get 1 point for just making this statement, slope is k squared. That's why we want to start right out with it. When we are marking up our graph, we want to show we know very clearly what we're talking about and there can't be any confusion. We might make a mathematical error, but the rater, when they go back and look at our work, we want to show them that we knew what we were doing, even if we made a clerical error. Having correct conceptual understanding is far more important than getting the correct answer. So we want to make the biggest triangle possible because that gives us the biggest numbers, which reduces the overall error in our judgment in reading the numbers. I will identify this as delta y. This is a point of 12, 3.5. There's another advantage of making it as large as possible. When it goes off the grid, it eliminates our judgment, so it makes it doubly precise. Not only is it large, but our error in reading is less. And we have a delta x here like so, and we recognize that point is 0, 0. Going back to our calculation, we have the square root of delta y, which was 3.5 minus 0, all over 12 minus 0. And that gives us a value equal to 0.540. The data we have going into it has only 2 significant digits, so we can only report 2. K is 0.54. We should ask what the units are, and just glancing ahead, we can see the next question is asking us for the units. Simple matter of finding the units in this case is to put them in under the radical. 3.5 was the time squared, second squared, and the 12.0 was 1 over meters. So the units of slope, which we already had figured out, the units of slope, which are second squared meters, when we take the square root of second squared meters, we would then have seconds times the square root of meters. Square root of second squared is seconds times the square root of meters. And we now then have our answer with the units for K.